All right. So in the last unit, we talked about how to factor polynomials, and we spent a long time on that, multiple weeks worth of time on factoring polynomials. So hopefully at this point, you feel good with that, you feel comfortable with that, because as we move into this next unit, we're not done with that. We're not going to learn any new methods for factoring polynomials in this unit, but we'll have to factor polynomials on basically every single problem in this particular unit. So you're going to get a lot more practice. And if you find yourself getting stuck on certain problems, that might be a sign that you need to go back to the last unit and review some of your notes or some of the videos or some of those practice problems that we did in the last couple of weeks. Okay. This unit is on rational expressions. So that word rational is a vocabulary word that we've talked about before. The first time in this class where we talked about rational things was when we were talking about numbers, and we talked about the set of rational numbers. Think back for a minute, if you would, please. Do you remember what rational numbers were, or what we said that that word rational was really all about? Rational refers to fractions. Okay, so rational numbers were numbers that could be written as a fraction. Right now, what we're going to be dealing with are rational expressions. And what that means, it's a fraction that has a variable, and specifically the variable will be in the denominator, in the bottom of the fraction. And so what we're going to spend the next few lessons on is how to work with those. In this lesson, we're going to talk about how to simplify rational expressions. That's all we're going to do in this lesson, is just simplify them. And then in subsequent videos, we'll multiply, we'll divide, we'll add, and we'll subtract. So it's all the basic stuff that you did with fractions back in elementary school. In fact, all of the things that you learned in elementary school are basically the same when it comes to things that have variables as they are with things that have numbers. There's really only one key difference, and that's what we're going to talk about in this video here. So with that said, let's get started. We only have one learning objective for this particular video, and that's to be able to simplify a rational expression. So what I would like to do to start with, and we'll probably do this in just about every video, is I'd like to start by going back to elementary school or middle school or wherever it was where you did these the most, wherever it is you remember learning these. I want to start by going back and doing a problem like you would have done there. So right now I want to simplify 4/6. Okay, so take a second and actually do that problem, please. Okay, so hopefully you paused the video and you did that problem, and hopefully you got the answer of 2/3. That is the right answer, is 2/3. The way most of us would do this problem, myself included, this is what I would have done, I believe, is I would have looked at these two numbers and said, hey, these can both be divided by 2. And so in my mind, I wouldn't have written this, right? So this is, me in my mind, I'm thinking 4 divided by 2 is equal to 2. And I'm thinking 6 divided by 2 is equal to 3. And so based on that thought, I can take this and simplify it into that. And so that's what I would have done if I was you, okay? But I want to consider a slightly different way. Not because I think it's important for you to learn a different way. If you've got a way that works, use the way that works, right? The reason I want to consider a different way is because, as I mentioned a minute ago, there's one key difference between working with numbers and variables, and it happens right here. You see, when I look at 4 and 6, I can just know that they're both divisible by 2, because way back in 4th grade, Miss Gavette made me memorize all my times tables for 2. And so because of that work in my life that she did, I can just look at these and say, I know I can divide by 2 because I've memorized that. The issue is when we're working with variables, it's hard to look at something and just be like, I think I can divide that by 3x minus 5. Most of us don't have that skill. And so to be able to go through this thought process, well, we just can't when there's variables. So I want to consider another way that we could have done this exact same problem. Okay, so I'm not going to do a different problem, not going to make it big and fancy. I'm just going to do the exact same problem. Another way that we might have done this problem is we might have thought to ourselves, 4 is the same as 2 times 2. And 6 is the same as 2 times 3. Okay, I'm going to pause there for a second. You might be thinking, why on earth would I do that? Well, the punchline's coming soon. Stay tuned and you'll see why you would do that, okay? But hopefully, whether you agree that you would or would not do that, hopefully you agree that these are equal, right? 4 is the same as 2 times 2. 6 is the same as 2 times 3. And so therefore, 4 over 6 is the same as 2 times 2 over 2 times 3. Okay, so even though we might not think to do this, hopefully we agree that it's mathematically legal, that this is a valid mathematical statement right now. Now, the reason why that's helpful, you might recognize, it's because we know that anything divided by itself just equals 1. And when you multiply something times 1, the 1 doesn't do anything. You just get that something is what you get. In other words, the 2 over 2, it just cancels out. It's like it's not even there. And what you end up with as a final answer is the 2 over 3 that's left, the part that does not cancel. Okay, now again, I'm not suggesting that you change the way you simplify fractions with numbers and start taking 4 over 6 and rewriting it like this and simplifying it that way. That's not my suggestion. My point is that you could, if you wanted to, that this is a method that does work. And that's important because this is the method we'll use with variables, because we may not have learned our times tables for x and x plus 3 and 2x minus 5 and things like that, but we have learned how to factor those things. And so if we can factor our polynomial and look for common factors, then we can cancel those out, and whatever's left, that becomes our simplified fraction. Okay, so with that said, let's try one. So here's example number 1. In example number 1, we're going to take 2x minus 4 and write it as a fraction with a 2x squared minus 4x plus 6. Okay, now I want to address one thing real quick before we get started, and that's order of operations. Aunt Sally, she rears her head right here in the middle of this problem, because some people would be tempted to say, oh, look, there's 2's and there's 4's, there's all kinds of stuff that cancel. I can just start drawing lines, canceling things out, making them go away. But there's this plus sign. And remember, the way fraction bars work, fraction bars act like they're a grouping symbol, which means all of this stuff is locked together. And all of this stuff is locked together. And so because this has a plus 6 and this one does not, I cannot just start canceling things as I go. In other words, moral of the story, I must start by factoring. That is what I must do, okay? So all of these problems, we must simplify by factoring, okay? There's just simply no way around it. And so what I want to do is I want to give you a couple of helpful hints. This is not a strict procedure. You can get the right answer by ignoring what I'm about to show you right now. But I have found this to be useful in my career. The first helpful hint that I'm going to suggest is that you start by looking for greatest common factors, okay? So try greatest common factors first. That's what I'm going to recommend. All right, so let's do that. In the top, there's a 2x minus 4. Do 2x and negative 4 have a common factor? Hopefully you recognize they do. They can both be divided by 2, so that's my common factor. Now, 2 times what equals 2x? Well, that's 2 times x. And 2 times what equals negative 4? Well, that's negative 2. And so I have just factored the top using greatest common factor. In the bottom, I might be tempted to try and do this with grouping because I've got 3 terms and it just looks like something that I should do grouping in. But I remember Mr. Root suggested try greatest common factor first. So that's what I'm going to do. I'm going to try greatest common factor first. So 2, 4, and 6. 2, 4, and 6 can all be divided by 2. This has an x squared, this has an x, but this does not have a variable. So the most I can factor out of this is a 2. I can't factor anything else out. So what would be left? Well, 2x divided by 2 is going to be an x squared. 4x divided by 2 is going to be a negative 2x. And 6 divided by 2 is going to be a 3. Okay? So now I can see, oh, look, there is a common factor in the top and in the bottom, so they can cancel each other out. And that leaves me with an x minus 2 in the top and an x squared minus 2x plus 3 in the bottom. So I have tried greatest common factor, and I found that it helped me. I ended up with smaller numbers, so I ended up with something that's more simple. Okay, then the next thing I would do is try other methods. Okay, so the other methods we talked about, well, we had lots with grouping. So that's where I would start first, is with grouping for sure. But you also might try doing things like difference of squares or perfect squares or things like that. In this case, I don't have any square numbers anywhere, so I can rule out perfect squares and things. Grouping is a possibility in the bottom, but notice if I did a 1 times a 3, I would get 3. The only factors of 3 are 1 and 3, and they do not add to equal 2. 1 plus 3 equals 4. It doesn't equal 2. So this will not factor. So that means this doesn't work. Okay, so I tried it, it didn't work, done with that. I move on to the final thing, and the final thing is just how do you know when you're done? And you are done when nothing else factors or cancels. That's when you're done. Okay, if nothing else factors or cancels, then you are done. Okay, so this is the basic idea of how to do these types of problems. We're going to start by trying to factor everything using greatest common factor. Then, if we can't use greatest common factor, or even if we can, we'll move on and try and use any other method that works. And once we've tried everything and nothing else works, that's how we know we're done. All right, so that's our basic process. Let's take a look at a second example. Example number 2. Okay, so in example number 2, let's suppose that I have a 2x squared plus 7x plus 3 divided by x squared minus x minus 12. Okay, so we said we wanted to start by trying to do greatest common factor. So if I look at the top, well, I've got even numbers and odd numbers, so there's not a common factor with the numbers. Some of them have x's, but some of them don't. So I cannot do greatest common factor in the top. When I look at the bottom, again, none of my numbers have anything in common. These have x's, but this one doesn't. So there's no greatest common factor in the bottom. Okay, so I've tried this, it didn't work. I move on to other methods. And like I said, the method that we probably want to focus on the most, so I'm going to say especially consider grouping. Because remember, grouping is that one method that we looked at that always works. So we want to especially consider grouping. So it turns out, I'll kind of jump to the punchline here. It turns out that both of these can be factored with grouping. So what I would recommend or ask you to do now, pause the video right now and try and factor both of these with grouping. Just treat them like they're separate problems. So try to factor the top with grouping first. Once you get done working through that one, then try and factor the stuff in the bottom with grouping. Once you've tried them both, then resume the video. All right, so hopefully you factored both. This I'm going to do just relatively quickly because we've been doing a lot with grouping lately. So hopefully you're comfortable with this. But what I would do is just on some scratch paper, or in this case, down underneath of the problem, wherever it is you've got space for some scratch work, I would do these. So I'm going to do 2 times 3, that gives me 6. Factors of 6 that add to 7, that's 1 and 6. So I'm going to say 2x squared plus 1x plus 6x plus 3. Remember, you can write these in any order. You'll get the same answers, just your steps will look different than mine. I'm going to factor the first two. They have an x in common, and that leaves behind an x plus 1, or 2x plus 1. That means this also has to have a 2x plus 1 in common. So I must have divided out or factored out a 3, and that seems to work. So I get a 2x plus 1 for my common factor, and an x plus 3 for what it was distributed to. So there's my first one. Same thing over here. 1 times 12 gives me 12. Factors of 12 that subtract to equal 1. Well, that's got to be 3 and 4. And I want to arrange them so that the 1 is negative. So I'm going to do a positive 3 minus 4. So I've got an x squared plus 3x minus 4x minus 12. In the first group, I can take out an x. And so that means this second group also must have an x plus 3. So if I divide negative 12 by 3, I must have factored out a negative 4. And so I end up with this for my factorization. Okay, so the thing in top became a 2x plus 1 times an x plus 3. And the thing in the bottom became an x plus 3 times an x minus 4. And so again, I see I've got an x minus 3 in the top and the bottom both, so they can be canceled. And so I end up with a 2x plus 1 over an x minus 4, and that would be my final answer. I know that I'm done because neither of these factor, and there's nothing else that cancels. And so that's the end of example number 2. Okay, let's wrap this video up with one final example. Okay, in this last example, example number 3, we are going to divide a 4x squared minus 16 over a 4x squared, I'm sorry, I just lost my train of thought. Let's say plus 24x plus 8. I'm sorry, not 8, 32. 32. There we go. Okay, there we go. Sorry about that. So we've got that written down. Again, same thing. We've gone through this process now a couple times. We've got the basic idea down. We want to start by trying to identify greatest common factors to see if anything cancels. Then we want to try other methods like, for example, grouping. But don't forget, we also did difference of squares and other things like that. You'll know you're done if nothing else cancels. So what you should do first, pause the video and try to do greatest common factor. Then try to do other methods. Once you've done as much as you think you can, resume the video and see where we end up. All right, so hopefully you've tried this, or at least part of it. Hopefully you recognized in the top, both of these things can be divided by 4. So that leaves, whoops, this would be a minus sign. That leaves this, okay? They both can be divided by 4. In the bottom, everything here can also be divided by 4. So that leaves this in the bottom. Okay, so my 4s can cancel. Now I've done my greatest common factor, so now I move on to try other methods. In the top, I notice that these things are both squares, right? X squared is a perfect square, or I might think of this as 1x squared. Still, that's a perfect square. 4 is a perfect square, that's 2 squared. So I can do this with my shortcut for difference of squares. And that shortcut said take the square root of the first thing. So square root of x squared would be x. Take the square root of the second thing, square root of 4 would be 2. Write that down 2 times. give one of them a plus sign and one of them a minus. So that would be my first thing there. Now this, I don't have any perfect squares. So for this, off to the side, I'm doing some scratch work, and I'm doing this one with grouping. 1 times 8 gives me 8. Factors of 8 are these. The two that will add up to equal 6 are these two. So I'm going to rewrite this as x squared plus 2x plus 4x plus 8. From my first group, I can take out an x. This has to have the same stuff in parentheses. So dividing 8 and 2, I must have taken out a positive 4. So I've got my common part is an x plus 2. And then the different part is an x plus 4. So that's what my bottom becomes. The bottom becomes x plus 2 times x plus 4. So I see that I've got an x plus 2 in the top and the bottom, so they can cancel. So my final answer becomes x minus 2 over x plus 4. Again, I can't do anything else because nothing else factors. And I can only cancel things that are factors. And because these can't be factored, I can't cancel. So I can't cancel these x's. I can't cancel the 2 and the 4 because they have these plus and minus signs associated with them. I'm done right here. And that is my simplified answer. All right, so thanks for watching this video. There will be more videos where we do adding and multiplying and dividing and other stuff. But for now, you should do the homework problems where you're practicing simplifying expressions. Thanks for watching. Have a good one.